Reinventing Cities: How to Design a Zero-Carbon, Resilient and Sustainable Project. Urban development defines our cities, from iconic skylines to historic architecture. Cities are where we live, work, study and play. But buildings are one of the biggest sources of greenhouse gas emissions, accounting for over half of total urban emissions. That's why cities and the real estate industry have a huge responsibility to fight climate change and accelerate zero-carbon urban development. The first step is transparency and accountability towards carbon emissions. Urban development projects therefore need to produce clear and reliable carbon assessments. But what exactly is a carbon assessment? A carbon assessment is a method to account for a project's total greenhouse gas emissions throughout its life cycle, from the construction, operational, and end-of-life phase. This whole-life approach enables the assessment of a project's emissions. In addition to minimizing its own emissions, a project may also reduce emissions outside of the site-specific scope, for example by offering the surplus green energy produced on site to neighboring buildings. We call these avoided emissions. Finally, a project can capture emissions through activities such as reforestation and tree planting. These are called sequestered emissions. When striving towards zero carbon, the first priority is to minimize the emissions of the project, then to compensate the remaining emissions with avoided and sequestered emissions. Beyond these key principles, there is not one single methodology for carbon and life cycle assessments. Using globally recognized tools and frameworks is therefore recommended. Now, let's see how to reduce a project's carbon footprint. There are three main factors to consider. First, the highest priority lies in improving energy efficiency in buildings. We need to design buildings that consume as little energy as possible for heating, cooling, hot water, lighting, and electrical services. Applying passive house design standards, retrofits, and making it easy for end users to monitor their energy consumption will make a big difference. Clean energy is also key. Installing photovoltaic and solar panels, ensuring a connection to district energy systems, facilitating on-site energy storage, and purchasing off-site renewable energy will benefit the wider community. The second most important consideration is choosing the right construction materials and waste management options. We should prioritize building retrofits over demolishing old buildings or building new ones, and choose construction materials with lower emissions in the extraction, manufacturing, transportation, and end-of-life phase. For example, timber and low-carbon concrete. Reusing and recycling construction materials and operational waste is also of great importance. The third most critical carbon contributor is mobility. All projects should encourage walking, cycling, and public transport as first choices of transportation and provide easy access to shared and low-emission vehicles. Additionally, challenges to designing a climate-safe and sustainable future should be considered by improving resiliency against climate hazards such as extreme heat, storms, flooding and droughts, hosting new ecological services, fostering sustainable behavior and creating green jobs, promoting biodiversity, urban agriculture and local food productions to increase self-sufficiency, integrating sustainable water management techniques, and finally, making sure environmental performance comes with community benefits and high-quality design. This is how we reinvent our cities. Cities that are decarbonized and sustainable, but also livable, enjoyable and inclusive. That is the future we want.